Hello, this video is some notes for you on mixture separation, which is kind of one of the beginning things we're going to look at here in chapter 4. The first one we want to talk about is filtration. Filtration is about separating it by particle size or its ability to basically go through a bunch of little holes. Even something like filter paper has a bunch of little holes in it that allow certain things to go through, but not others. When you pour something through a filter, the big particles, things that don't dissolve, get trapped. Others pass through. Water will go through filter generally. Something like sand, even though the grains seem small, they're much larger than the openings in the paper, and so they're trapped as a result. The video clip here is a little bit of a review about folding up filter paper to use during filtration. The video here shows a couple of options. Either option would work. You can see fold it in half, fold it in half, fold it in half again. Okay, notice how it kind of creates that cone shape, which is kind of what you're looking for. Okay, this is the one that I kind of generally go with. You're going to end up folding it in half, fold it in half, fold it in half a third time. Once you've done that, then you can go through and you'll kind of see here, just open it up. I always like opening up the inside after you fold it together 3 times, but it's kind of up to you. And as the video says, make sure it fits into the funnel as a result. Okay. The next mixture separation technique is something called distillation. This is separating it by its boiling point. For example, crude oil is a mixture of all different kinds of oil, gasoline, kerosene, jet fuel, all of that. And they all have different boiling points. If you go through and boil off a part of it, it's going to pass through the condenser. It's going to cool back down from a gas into a liquid again, and it'll separate itself out. This works, again, really well with liquids. That's kind of the main application. Okay, and here's an example. Okay, you can see here the flask on the right contains some kind of liquid, and as the vapor goes up, it passes through a tube which allows it to cool back down, and the end result collects. You notice how the stuff in the flask on the left is much clearer. I think this is just food coloring in water, is what they're doing in the video here. But ultimately, the end result is you get clean water on the other side. The last one I want to point out here is decanting. This works really well when you have something that's a solid that you're trying to keep, or I guess get rid of, mixed together with a liquid. If you have the sediment in there, if you're careful about how you pour it out, you can pour out the liquid and you can leave the sediment. Sometimes you want the sediment. Sometimes that's what you're getting rid of. It just depends on the mixture separation. This illustrates kind of the process of decanting a little bit here. You'll see, just take a stirring rod. This works really well to keep that sediment in the beaker. And you just kind of pour. You use the stirring rod to kind of keep everything held in there. You pour out the liquid. You'll notice that the sediment tends to collect there at the bottom. That is a pretty brief summary of mixture separation techniques: filtration, distillation, decanting. These are all common techniques in the lab. These are all techniques that you'll need to use at some point this year, although maybe not in your mixture separation challenge.